Okay, Spartan fans, we're going to look at rate of change. So as a refresher, remember that average speed and instantaneous speed are not the same. So if you're going to find your average speed, you're going to have your distance divided by the time. And that's going to be how fast you were going, right, on average. But it's not the same as instantaneous. So remember that for instantaneous speed, I have the limit as h approaches 0 of the f of x plus h minus the f of x all over, right, x plus h minus x, which of course is just h. So this is instantaneous. And we're going to see today that it's not just considered the formula for instantaneous speed, or velocity, I should say, whichever. This is not just going to be for instantaneous velocity. It's also going to help us figure out slopes at different places on a curve. How can a curve have slope? Let's take a look. Let's look at the graph of a parabola. Let's look at x squared plus 1. Okay, take a minute and draw a nice sketch of this curve. Okay, there's your graph of x squared plus 1. Let's look at the tangent line at x equals -1. So let's look at the tangent line at x equals -1. Let's just kind of sketch that. Of course, it's not going to be exact, but ish. So just like when we were finding instantaneous velocity at a specific time, I think one of the examples we did, it was like a water balloon, and I wanted to know at exactly the velocity of the balloon. It was 3 seconds perhaps. Well, guess what? I'm going to use that same philosophy to find the slope of the tangent line at this specific point. So to find the slope of the tangent line, I'm going to use the exact same formula that I used for instantaneous velocity, because I want to know at this exact instant what's happening. So to find the slope of the tangent line, I'm going to do the limit as h approaches 0 of the f of x plus h minus the f of x, of course, all over h. Oops, sorry about that. It's the same concept as instantaneous velocity. I have this curve. I want to know what's happening at exactly this point right here. So I know my f of x is x squared plus 1. And let's find the f of x plus h. So the f of x plus h is going to be x squared plus 2xh plus h squared plus 1. So let's just plug generically in. We'll come back to x equaling -1 in just a second. Okay, so this is going to be the limit as h approaches 0 of the f of x plus h, which we just found was x squared plus 2xh plus h squared plus 1. Be careful with the subtraction, minus the quantity of the f of x. So that's x squared plus 1. And if you'll recall, at some point, this h in the denominator has to reduce out. If it doesn't, right, you can't just plug in 0 to the denominator. It's a problem. We have to somehow get rid of that h. So hopefully something's going to factor and reduce. Go ahead and take a minute, factor and reduce. As promised, so, simplify, blah, blah, and you're left with you're left with 2x. Okay. What you've just found is this represents the slope of a tangent line at any point on the curve of y equals 2x. Oh, sorry, on the curve of x squared plus 1. There we go. Okay, so you get 2x. What's happening at -1? So at -1, at x equals -1, plug in, the slope is -2. And you know what? That kind of looks doable, even on my approximated graph. Yeah, that looks doable. What if I ask you at x equals, how about 2? So if I ask you at x equals 2, I'm just going to approximate a tangent line. So 1, 2, it's about here-ish. X is 2, yeah. I don't need to go through all of this work. I don't need to go through all of this work. I already found the slope of a tangent at any point. So at x equals 2, 2 times 2 is 4. That looks doable. It's possible that the slope of this line is 4. Okay. What if I wanted you to find the actual equation of the tangent line? Well, you've been doing this forever. So the equation of the tangent line, we have x is -1. So on the graph, if x is -1, or you can just look, if x is -1, y is 2. So you have a point, -1, 2. You have the slope is -2. Point slope form, y minus 2 equals -2 x plus 1. So that is the equation of the tangent line. Now this is going to sound a little funky, but instead of saying the slope of the tangent, we call it the slope of the curve. All right, so this is instantaneous velocity. It is also referred to as the slope of the curve. You are going to see so many different letters used for the slope of the curve, the instantaneous velocity. H is generally what it is. This formula is going to, wow, are we going to be seeing it a lot? Okay, let's look at an example where we find the slope of the curve, the equation of the tangent. We're going to look at a new concept called the normal. So let's just start there. The normal is the slope of the line perpendicular to the tangent. So there's the tangent line, and then there is the quote unquote normal line. Okay, so let's say you have something like the f of x is x squared minus 4x. It's a parabola. We deal a lot with parabolas. Okay, doesn't even matter what point I ask you. Let's just find the equation for the slope of the tangent line at any point along this curve. So we're going to find the slope of the tangent line at any point along this curve. Okay. You're going to see it referred to as the slope of the curve. You're going to hear it referred to as the slope of the curve. So when you see that, like, what are you talking about? The slope of the curve. I think we're mathematicians, you know, we want to sound super smart. So we say slope of a curve. All right. The more you write it, the more you're going to know it. The limit as h approaches 0 of the f of x plus h minus the f of x all over h. You want to find the f of x plus h, plug in, take a minute and do that now. Okay, so I got 2x minus 4. Now I can ask you to find the equation of a tangent line anywhere on this curve. Let's do -1. So I'm going to ask you for the equation of the tangent line at -1. Okay, well, if my slope is 2x minus 4 and x is -1, I believe that would be, how about -6? Yeah. Then if I have the point, well, I sort of have the point. The point on the curve is -1. Plug in -1, you get 1 plus 5. So my line is y minus 5 equals -6 x plus 1. And the equation of the line that is normal so the equation of the line, actually they call it the normal line. They don't call it the line that is normal. Equation of the normal line. So it's going to have perpendicular, slope is going to be perpendicular, which is going to make it positive 1/6. Right, opposite reciprocal. And now still goes through the same point, but it's 1/6 times the quantity x plus 1. It all comes down to the f of x plus h minus the f of x all over h, being able to simplify, factor, and reduce. Let's take a look at a piecewise graph and find some slopes of tangents, etc. Okay, how about something like The f of x is equal to negative x, x less than 0. X squared minus x. It already looks funky, huh? Yeah, x is greater than or equal to 0. And I want to know, does the curve have a tangent line at x equals 0? So let's figure out what's going on. And this would be a really good opportunity to review limits. Take a minute to graph the function. This is closed at the origin. Negative x, open circle at 0, 0. But the second curve overtakes that. So this is a great way to review a bunch of stuff. This should be a little bit, it's kind of like a parabola here. Okay, so let's just review all kinds of things. First of which, I'm not sure why this is dotted. Okay, that looks better. All right, so let's talk about continuity. Clearly, the graph is continuous for all values of c within the domain. It is continuous for all values of c within the domain. In this case, our c is 0. All right. Does the limit exist? Does the limit exist? We always use 0. It's kind of tiring after a while. The limit of the function as you approach 0 from the right, falling down and you hit 0. The limit is as x approaches 0 from the left of this function is 0. The value of the function at 0 is 0. So this function is indeed continuous at 0. The right hand equals the left hand, therefore the overall limit exists, and the exact value of the function is the same as that limit, so it's continuous. I know that wasn't part of the question, but we were going to do that anyway. Okay, let's find the actual slope of this tangent line. Don't be fooled. The slope of the tangent at 0 is actually not 0. So let's do the limit. As x approaches, not x, h. So we're going to do h approaches 0, but we're going to do this twice. We're going to do as h approaches 0 from the left. So as I'm approaching from the left, the equation that I'm going to use is negative x. So this is going to be the f of x plus h. I'm just going to write it out because I'm so used to it. Okay, so we know that it goes through the point 0, 0. So there's my f of x, it's 0, and then the f of x plus h. So from the left, I am using the equation negative x. So the f of x plus h, be careful, is negative quantity x plus h. Okay, but if x is 0, we just have negative h. So this is going to be the limit. So tired of that. The limit as h approaches 0 from the left is going to be negative h minus 0 all over h. Okay, again, how did I get that? The f of x plus h, if x is 0, that's negative h. The f of x, we already know, is 0, and then h is h. So this is going to be, how about negative 1? Let's do the limit as h approaches 0 from the right. So from the right, the equation I'm going to use is x squared minus x. Okay. So this is going to be the f of x, which is 0 plus h minus the f of 0, which we already know, all over h. Okay, so let's just do some simplifying here. 0 plus h, I believe, is h. So this becomes h squared minus h. I'm using 0 because that's the point that I asked you to find. Plug in 0 plus h, which is h, and I plugged it in here and I got x squared minus x, which is now h squared minus h, minus the f of 0, which is 0, all over h. So I believe this is the limit as h approaches 0 from the right of h minus 1, which is -1. So yes, there is a tangent line and its slope is -1. There is a tangent line and its slope is -1. Okay. Let's look at I'm going to give you the slope and you tell me where it is on the curve. So I'm going to give you that given that the f of x is 3 minus 4x minus x squared. We're going to be dealing with parabolas so often. I want to know at what point is it horizontal? Okay, big thing there is the slope needs to be 0. Slope needs to be 0. Okay, well, what's the slope? Guess what? F of x plus h. Oh my goodness gracious. So the limit as h approaches 0 of the f of x plus h minus the f of x all over h. But I want that to be 0. That's how I'm going to find my slope. I want it to be 0. Okay, this is going to require a little bit more plugging in. It's going to take a little bit more work. Trying to adjust this a little bit here. Oh no, what just happened? Okay, there we go. Okay, f of x plus h. I'm not sure you really need me for this. I'll get you started. So this is going to be 3 minus 4 x plus h minus x plus h squared minus the quantity 3 minus 4x minus x squared all over h. Go for it. Great. So if I asked you at what point is the slope -3, we could set it equal to -3. At what point is the slope 25? We would set it equal to 25, but I'm asking you specifically about being horizontal, which means that the slope is indeed 0. So this is at point. Well, first let's figure out when this equals 0, you get x equals, how about -2? Okay, but certainly we need to figure out what the y value is that corresponds with this. So it would be at the point -2, 7. Let's do one more. Let's take a look at a word problem. If you have your book, we're going to look at number 24. 24, page 88. Rocket launch. So I'm already assuming there's going to be some kind of velocity going on here. So I try to do, even problems in the book, and that way you can hopefully mirror those when you're trying to, if you're stuck on an odd problem. At t seconds after liftoff, the height of a rocket is 3t squared feet. So the height is 3t squared. And what do we ask to find? How fast is the rocket climbing after 10 seconds? Well, essentially, this is instantaneous velocity. At 10 seconds, okay, so that's going to be 10,300, I believe. So the limit as h approaches 0 of the f of x plus h, which in this case is 10. That is not correct. X is 10. So instead of x plus h, it should be 10 plus h minus the f of x we already know is 300 all over h. Okay, so this is the limit as h approaches 0. Let's see, this is going to be 3 times 100 plus 20h plus h squared minus 300. You get the point. I would hope that by now you're pretty good at doing all of your multiplying in your head. This is the limit as h approaches 0. 300, 300, so we get 60h plus 3h squared all over h, which is the limit as h approaches 0 of, how about 60 plus 3h, which is 60. I don't know what our units are. Feet per second. Okay, so that is pretty much section 2.4. I think that this video covers enough information to get you through what will be tonight's assignment and the asynchronous assignment tomorrow. But yeah, you should be good to go.